Hey everybody, and welcome to section 310. We'll just abbreviate as rates. The full aim says find average and instantaneous rates of change. Understand the instantaneous rate of change is the limit of the average rate of change. Interpret the derivative as a rate of change in applications, including velocity, speed, and acceleration. So we've hit on this formula a lot through the year. Average rate of change, we see it again. It's a slope formula, and this just takes a function on an interval and finds the average slope, the average rate of change. How fast on average is the function changing on interval AB? If we turn this into a limit, the instantaneous rate of change as B approaches A, it finds how fast is it changing at a specific point. So just modifying this slightly, it turns into a derivative, the limit, which we can in turn interpret as the derivative as we get infinitely close to a point. Here's the alternate definition of a derivative, which should be familiar to most of you. Limit as x approaches a, f of x minus f of a all over x minus a, and that is notation for the derivative right at point A. So in some sense, this section is sort of a review of that. We will look at a example, and this is example directly from the aim sheet. It says you're filling a bucket with water and the height h centimeters of the water after t seconds is given by the formula h of t equals 4t raised to the 2/3 power. Question is, how fast is the water rising 30 seconds after you start filling the bucket? Okay, so this is a function for the height of water in a bucket. So we want to know, the question is, how fast is it changing right at 30 seconds? Real simple. We're just going to take the derivative, which answers the question how fast, and at what time. We said 30 seconds. So notice our derivative here, chain rule, 2/3 at 4t to the negative 1/3 power times 4, simplifies to 8 over 3, 4t to the negative 1/3, and then we are going to plug in 30 to that, 8/3 times 4 times 30 raised to the negative 1/3 power. Quick calculation in the calculator. It is, the height is changing at a rate of 0.541 centimeters per second right at that time. So that answers the question of how fast is it changing. Now it may be different at different time. Maybe it's different at 20, at 15 seconds, but at that point in time, that tells us how fast it's changing. Alright, and to close this out, physics applications, we get into more and more in this as the different sections go by. For you physics students, this should be familiar. Position is where an object is located at some point in time, t. And so rather than p of t, they use notation s of t for position. If you take the derivative of position, you get velocity. Velocity is two things. It's speed and direction. A direction is positive or negative, and we're only going to worry about a linear motion. So if a particle is moving vertically, positive means up, negative means down. If the particle or an object is moving horizontally, plus is to the right and negative is to the left. Rate of change of position is basically what we're talking about here, and that's going to be denoted as a v of t. And then if you take the derivative of velocity, you'll get acceleration. Acceleration is the rate of change of velocity, a of t. Okay, so on to the side here, we notice these are the big three. Alright, we'll be using these functions a lot. Down here, just to close it out, v of t, you can express that as s prime of t. A of t is f v prime of t, or you could say the double derivative of position, s double prime of t. Now there is one more. You can in fact take the derivative of acceleration, and that is known as the jerk. You can sort of equate that to sudden or abrupt changes in acceleration. That is what the jerk is. And it's like, think about if you're driving in a car and you slam on the brakes, or you push the pedal down all the way, your head will jerk back and forth. Sudden and abrupt change in accelerations, and that is the derivative of acceleration. Just call it a prime of t. We won't use it too much, but it is just something extra to know.